This is the third in a series of videos that I put together to describe and demonstrate and show some of the work that I've been doing with a friend of mine that I've entitled A Little Magic with IoT, or the Internet of Things. We're adding some animation and automation to some displays that he's created in his basement themed against Diagon Alley from Harry Potter. In the first two videos, I covered kind of the overview of what our goal is behind this initiative, as well as the design goals that I set for myself in creating these modules. In the second video, I demonstrated the prototypes that I created of 6 of the modules. In this video, I'm going to go over some of the upgrades that were made to the modules, specifically in how they were created. Initially, the prototypes were created in prototype boards with wires and resistors and LEDs all plugged into a breadboard. And now changing those over to a perf board where they're actually hard soldered in and so on. So that's what you'll see in this video. If you remember in the prior video, I had put together these modules that I had created that would be controlled by a Raspberry Pi to trigger certain events to happen. This is an ESP8266 chip within a Wemos D1 Mini. It's an Arduino programmable controller in a breadboard connected to a proximity sensor that's an ultrasonic proximity sensor. It sends out a signal out of one of these, echoes back off of a target back in here, and then the logic in the chip calculates the distance that took based upon the time that took to respond. But I'm showing this in this video because if you remember, if you go back and see the other videos, all of the other modules that I've created look similar. They're in a breadboard, they've got LEDs, a button, the wires are on top. The main difference is the sensor or the actuator that's plugged in. In one case it was the proximity, like here. There was also an IR sensor, but then there was other cases where it was a servo motor that was driven by the module. There's another one that drives an LED module and a sound module. But they all looked essentially the same. And before installing these, I wanted to pretty them up, take care of the wires, but also make it a little bit more reliable so that things might not get pulled out, because these are just stuck in these little tiny holes. So if we take this and let me turn this around this way, that's the way everything used to look. And here is the new model, the new and improved model. All right. So if I move this over here, you'll see that now it's on a perf board. All the components are soldered into the board. The Wemos D1 Mini ESP8266 is mounted in so that it can be removed easily if it needs to be reprogrammed or replaced. I can reprogram it over the air, but this way I can replace it if I need to. Instead of all the ugly wires, that's all now copper traces on the bottom of the board connecting everything that needs to be connected. And instead of having the actuator or the sensor plugged directly into the board, I put in a jack that will allow us to create any length of wire out to the actuator or to the sensor, in this case the ultrasonic sensor. Otherwise it does exactly the same thing as this one. Red LED means it's running, or it's stopped. Green LED means it is active. The push button puts it into programming mode so that we can program it. So let me get this out of here a minute. I'm going to move this over here. Remember, this is the proximity sensor using ultrasonic sensor. I'm going to move this over here and move this one over here. And you'll see there's 3 different modules here. The one on the left, this one that I'm holding, is the IR sensor, right? There's an IR sensor here, LED. This one is the servo actuator, obviously, right? But you'll notice that the boards are all identical, right? I've laid them out identically, I've wired them identically. In fact, they're interchangeable by pulling out these chips. I can put a new chip in any of them and it will function as that chip. And then the only other difference is the jacks. Some of these are 3-wire jacks, as is the case with the servo and IR. In this case, it's a 4-wire jack. So we've gone from the prototype breadboards to the perf boards, which are more permanent. The next step will be to actually print out PCBs that these will mount to, but I'm not there yet. That's something I'll work on eventually. So that's just a quick update showing you what I've been doing with these wireless modules that will all be controlled by that Raspberry Pi. That is the one running Node-RED that will send all the messages out to these modules, and vice versa to trigger, as I demonstrated in the earlier videos. Thanks.